This is part 2 for lesson 2.4. Please note that this is a remake of previous lessons, and so the number problem in your book may not match the number problem in the video.
Okay, the next one, we've got a graph. You need a straight edge for this. And what you're going to do, you might want to color code this too, but what you're going to do is you're going to graph the line y equals 2x. So pause, graph the line y equals 2x. Okay, you're going to start at 0 because it has a y-intercept of 0, and it has a slope of 2, that's 2 over 1, so you're going to go up 2 and over 1. Okay, you can also go down 2 and backwards 1, but that's the line. I'm not able to use a straight edge on here, so sorry, it's kind of wiggly. Okay, now the next thing, I'm going to do it in a different color, and I'm going to graph line y equals 2x plus 3. So I want you to pause the video and graph y equals 2x plus 3. You're going to start this one at 3. You're going to go up 2 and over 1, up 2 and over 1. Notice that this has the same slope as the other one. So because they have the same slope, what do you notice about the two lines? Okay, you should say that they're parallel. So these two are parallel lines. They have the same slope. So question on number 4. How did changing the y-intercept, so we went from 0 to 3, how did that change the picture? So if I was describing how did the red line turn into the green line, what happened to it? Okay, what you should notice is that the y-intercept went up by 3, so it went from 0 to 3, but not only that, every single point went up by 3. Every single point was lifted by 3. So you're going to take the entire line, the whole red line, just lift it up 3 units. And so each point, and it's important to understand that each point in the graph rose 3 units. Okay, so then the next question is, what if we changed it to y equals 2x minus 4? What's going to happen to that? Okay, so graph that. What's going to happen? You're going to start at negative 4. Again, you're going to go up 2 and over 1. So this is another parallel line. Whoops, that went badly. Okay, so the question, how did the red line turn into the blue line? What happened? So if you look at this, the y-intercept went down from 0 to negative 4, so it dropped 4, but every single point also dropped by 4. So each point dropped 4 units. So it's like an elevator. The entire red line dropped. With the red to the green, the entire thing rose. So just it's being lifted or it's being pulled down every single point. And so the thing that we want to see about this is that when we add something or subtract something, so we start with this, if I add 3, it's going to lift the graph 3 units. If I subtract 4, it's going to drop the graph. And when I say the graph, I mean every point on the graph, 4 units. So adding 3 to any graph, and this doesn't just work for linear equations, and that's the great thing about this, it works for all equations. So if you have a graph, even though you may not know what the graph y equals 2 to the x looks like, you should know now that if I add 3 to it, it's going to take whatever this was and it's going to add it or lift it 3 units. If I did, instead of plus 3, if I did minus 4, it's going to take whatever graph that was and it's going to drop it 4 units. So it doesn't even matter if you understand what type of graph you're looking at. The transformations that happen on this graph are all the same. If we take a trigonometric graph like that, you don't even know what that looks like. But if I add 2, what's it going to do to it? It's going to raise it 2. What if I subtract 3? It's going to drop it 3. So even though you don't know what the graph looks like, you do know what's going to happen when you add 3 or subtract 2 or whatever. And so that's a really important thing to understand about the way graphs work. Okay, going to the next one, let's try another one. So the first one we're going to do is we're going to graph y equals x. Now before you go and graph this, this is what's called the parent function of all linear equations. Every linear equation is based on this one. Now, this actually should be the easiest linear equation to graph ever, but it's one that people struggle with a lot because they look at that and they're not really sure what to do with it. So before we go and graph it, let me ask you, what is the coefficient in front of the x? It's a 1. What is being added on here at the end? It's a 0. So that's in slope-intercept form, so that means you start at 0 and you rise 1, you run 1. So this is the parent function. Every linear equation is based on this one, and then it's transformed in some way. It's shifted up, shifted down, maybe getting steeper, less steep. So that's the parent function. Now, number 2, graph y equals 3x. So what's changing here? What's changing between number 7 and number 8? The slope is changing. It's going from 1 to 3 on the slope. Now, does that mean it's going to lift it up? How does changing the slope change the graph? So we're still going to start at 0, but instead of going up 1 over 1, we're going to go up 3 over 1, up 3 over 1, down 3, backwards 1. And so what's happening is this graph is getting what? It's getting steeper. Okay? So right here in number 9, how did changing the slope from 1 to 3 change the graph? Don't just say steeper. Okay, steeper is true. But the question, how much steeper did it get? It got 3 times steeper. 3 times as steep. Okay, these stairs in the green, those are 3 times as steep as these stairs in the red. Okay, next one. Graph y equals 1/5 x. So again, the slope is changing. So now it's going from 1 to 3 to 1/5. So if I start at 0 again, because the y-intercept is still 0, I'm going to go up 1 and over 5, down 1 and backwards 5. And so how would you describe that change on my graph? So if I'm comparing the blue to the red line got less steep. Okay, so it's less steep. That's true. How much less steep? It's 1/5. Whoops, 1/5. Instead of saying less steep, I'll say as steep. So it's 1/5 as steep. And so that's how you describe it. So don't just say it's steeper or less steep. Tell me how much more steep it is. Number 12, what will happen to a graph when you increase the y-intercept by 5 units? So this is like if I have y equals 2x plus 1 to y equals 2x plus 6. So I'm increasing the y-intercept by 5 units. So what's going to happen from the first graph to the second graph? Can you answer that question? Number 13, what will happen to a graph when you decrease the y-intercept by 12? So if you have y equals 2x plus 4, and I decrease that by 12, so I'm going to say 4 minus 12 is negative 8, so I'm going to go from there. That's a difference of negative 12. So what's going to happen to my graph? Okay, you should have been able to answer that question. On number 12, it's going to raise each point 5 units. So be specific. When I decrease it, it's going to drop each point in the graph 12 units. So the whole thing is going to be lower. Number 14, what will happen to a graph when you increase the slope? So when you go to 1 to 3 to 5, what's happening to my slope? It's going up 1 over 1 versus up 3 over 1 versus up 5 over 1. So it's going to get steeper. Okay, so it's going to get steeper by whatever degree. And what will happen to a graph when you decrease the slope? So it goes from 1 to 1/2 to 1/3 to 1/4. That slope is going from 1 to 1/2 to 1/3 to 1/4. So it's getting less and less steep. So these characteristics of a graph, when you add or subtract or when you multiply or change the factor of the slope, it's going to change how the graph looks, but you can predict that. Again, like I said, you can know even if you don't have any idea what a graph looks like. If I say I'm going to multiply that by 3, then that graph is going to be 3 times as steep, or the rate of change is going to be 3 times as much. If I add 2, it's going to be lifted by 2. And so these transformations on a graph, they're consistent in the way that they affect graphs throughout all families of graphs. Okay, number 16, graph these two lines. Y is equal to 2/3 x and y is equal to negative 2/3 x. So the difference is the slope. Graph them, and then which line is steeper? Explain. Come back when you're ready. Okay, you should have graphed your two lines. And as you're graphing them, you notice that on both of them, you're going to be rising 2, running 3. It's just a matter of the direction. So, question, is the blue line steeper because it's positive? The red line, is the slope is less than 1, so does that make it less steep? So 2/3 is greater than negative 2/3. Does that mean that the slope of the blue is greater than the slope of the red? What do you think? And how would you explain that? The way that I explain it is I think of stairs at my house. So if I have stairs at my house and I'm going up the stairs, it might be steep. If I come down the stairs haven't changed. The steepness of the stairs has not changed, just my direction is changing. It's kind of like when you look at a number line and you say, here's 1 and here's negative 1. So which one's further from 0? Is this one further from 0 because it's positive, and then this is less distance because it's negative? Of course not. It's just the direction that's different. And so when I look at the steepness of a slope, to tell which one is steeper, I'm going to look at the absolute value of my slope. And the greater my absolute value of the slope is, then that's going to mean that it's steeper. Okay, a slope that is greater than 1, okay, that's going to be steeper, and a slope, so the more greater than 1 it is, and less than 1 is going to be less steep. So it looks almost flat, all the way until you get a slope of 0, which is a horizontal line. Okay, you can get steeper and steeper until you get to a vertical line, but then it's so steep that it's undefined. This is a story problem. Mackenzie is skydiving, so think about that. So let's see, I'm not a very good artist, but we're going to jump out of an airplane, and you're going to jump, and you're going to come down, and then at some point, hopefully, your parachute is going to open, and so that's going to slow you down. So however fast you were coming like that, then it's going to slow you down, and you're not going to come down as fast. Okay, so the question is, 40 seconds after she pulls her parachute. So we're just talking about like, this is where we start our time. So this is time 0. Okay, so 40 seconds after she pulls her parachute. So once we go to 40 seconds down here, she is at 2,600 feet above the earth. Okay, she is 1,750 feet above the ground, 125 seconds. So, a couple minutes later, she's still above the ground, so she's floating down pretty slowly. I don't know if that's actually realistic. I've never skydived, but that's where we're at. So this is going to be 125 seconds. No, it's 1,750. Okay, so question, can you write ordered pairs reflecting what Mackenzie is doing? We've got 2 points in time, so write 2 ordered pairs. You need to think about which one is the input, which one is the output. So when you're dealing with something that's talking about time, time is almost always going to be your independent, because time doesn't depend on anything. Time goes on without any help from anybody. So after 40 seconds, that's going to determine how high she is. She was 2,600 feet above the ground. And then at 125 seconds, she was 1,750. Those are my 2 ordered pairs. Now, using 2 ordered pairs, are you still able, can you remember how to write an equation of a line using point-slope form? And then can you answer the questions that relate back to the equation? So I want you to pause the video. I want you to complete 18, 19, and 20. Then come back and make sure you did it right. Okay, first thing you're going to need to do is find the slope. So you should have done 2,600 minus 1,750 over 40 minus 125. And you're going to get, so you would have gotten negative 850 over negative 85. And so that's going to be negative 10. So that's my slope. So I'm going to write m equals negative 10. And then to use point slope form, I'm going to just choose one of my points. So I'll just choose one. So y minus 2600 equals negative 10 times x minus 40. So I'm going to simplify that. Watch your signs. I'm going to add 2600 to both sides. So I'm going to write it over here. Y equals negative 10x plus 3000. Okay, that's my equation. That's the answer to number 18. Did you get that? Okay, number 19. How far above the ground is she when she pulls her parachute? So when she pulled her parachute was when the time began. Okay, 40 seconds after she pulls her parachute. So that's when our time began. And so that's going to be our intercept. So it was, she was 3,000 feet above the ground when she pulled her parachute. How fast is she falling after she pulls her parachute? So again, after she pulls her parachute is when we're talking about. So which of those numbers tells us how fast she's falling? So if you say negative 10, that's okay, because I ask you about that, but you haven't described what's happening. So negative 10 means that she's falling 10 feet whatever. 10 feet what? So look at what your problem is talking about. It's talking about seconds. So 10 feet per second. That's what that means.